In this video, I am going to explain about model questions of classification of elements and periodicity in properties. So this chapter simply will be known as periodic table. We will discuss questions one by one. This is the first question. The electron affinity values for halogen show the following trend. Electron affinity of 7th A group or halogens will be F, Cl, Br and I. So this is expected order. Expected order of electron affinity. So but due to small size of fluorine, so very small size of fluorine that cannot accept electron very easily. So therefore order will be Cl, F, Br and I. So this is actual order. So this order is actual order is due to very small size of fluorine that cannot accept electron very easily. So therefore option will be A. F less than Cl, which is greater than Br, greater than I. Next question. So this is also very important. The covalent and van der Waals radii of hydrogen respectively are. So we know different types of order. That means different types of radii order. Radius of covalent, metallic, and van der Waals. This will be the order. So metallic radius will be also known as crystal radius. So order of different types of radii. So here they are asking covalent and van der Waals radius order for hydrogen, comma. When compared to covalent radius, van der Waals radius will be more. So compare the options. So in first option, when compared to covalent radius, van der Waals radius is more. In option B, both are equal. This is not possible. Option C, both are equal, not possible. Option D, covalent radius is more than van der Waals radius. That is also not possible. Therefore, option A. Covalent for hydrogen greater than van der Waals for hydrogen. If this is 0.37 angstrom units, this will be 0.8 angstrom units. When compared to covalent radius, van der Waals radius of hydrogen will be more. Therefore, option A. Next. So, in the first 100 elements, the number of S-block elements are. In first 100 elements, number of S-block elements are. So, we know S-block elements consists of first A, alkali metals. So alkali metals there will be 6 elements. 2A, alkaline earth metals. Here it will be 6 elements. And hydrogen 1 and helium also belongs to S block, helium 1. So total 6 plus 6 plus 1 plus 1. So total 14 elements. So these 14 elements belong to S block. Alkali metal 6, alkaline earth metal 6, 1 hydrogen, 1 helium. Total number of S block elements, so below 100, 14 elements. Therefore, option will be C. Next. Next one here. Argon, first it is converted to Ar plus, next Ar2 plus and Ar3 plus. Here it is given E1, second process E2, third process E3. So we know here removal of electron, so minus E. Removal of first electron from neutral atom, this is neutral. Atom, this is uni-positive ion, di-positive and tri-positive ion. So conversion from neutral atom to uni-positive becomes first ionization energy. Simply this is IE1, first ionization energy, removal of first electron from neutral atom. So E2 becomes IE2, E3 IE3. First ionization, second ionization, third ionization. So clearly we know IE3 greater than IE2 greater than IE1 due to increase of Z effective by the removal of electrons. So here IE3 means we can write it as E3, which is given in question. IE2 E2 and IE1 E1. So therefore option will be A. So this is decreasing order, E3 greater than E2 greater than E1, or we can write E1 less than E2 less than E3. Option A. So when compared to first ionization, second increases. When compared to second, third increases due to increase of Z effective nuclear charge for any element. Next question. Select the correct order of acidic strength of oxides. Here first option SiO2, silica, P4O10, phosphorus pentoxide or tetraphosphorus decaoxide, sulfur trioxide, chlorine heptoxide. Next, second option sodium oxide, magnesium oxide, sulfur dioxide, sulfur trioxide. Next C, CO2, carbon dioxide, dinitrogen pentoxide, sulfur trioxide, chlorine heptoxide. Next. So here we know non-metallic oxides are acidic in nature, metallic oxides basic. So in option A, SiO2 to Cl2O7 non-metallic nature increases or electronegativity increases. SiO2, P4O10, SO3, Cl2O7. So in this direction, electronegativity increases. Cl is most electronegative, therefore acidic strength increases. Or we can say non-metallic nature. Next, in option B also same. Na2O, MgO, SO2 and SO3. So in this direction same. Electronegativity increases or non-metallic nature increases. Non-metallic nature. Next, C option also same. CO2, N2O5, next SO3 and Cl2O7. Similar. Electronegativity increases or non-metallic nature increases. Simple question only. As the non-metallic nature increases, electronegativity increases. As the electronegativity increases, acidic strength increases. So therefore, option will be D. All options are correct. Due to increase of electronegativity or non-metallic nature. Next question. Which is correct order about increasing order of acidic strength of HX? HX is halogen acids. So here X may be F, Cl, Br and I. HF, HCl, HBr and HI. So in this direction, bond length increases. Bond length increases. Due to increase of bond length, it will give H plus ions more easily. So therefore, acidic strength also increases. So therefore, HI is most acidic. Due to more bond length, it can release H plus ions easily. Therefore, order will be increasing order. HF less than HCl less than HBr less than HI. This is the acidic strength. Increasing order. Very, very important question. So acidic nature depends on bond length. Next question. Fluorine is most reactive among all the halogens because of its So fluorine F2 molecule first dissociates into 2F. This is dissociation. Next, here F2 gas and F also gas. Next, F gas will be converted to F minus. This is electron affinity or electron gain enthalpy, addition of one electron. Next, F minus gaseous. When dissolved in water, that will be converted to F minus aqueous. This is nothing but hydration. So first molecule to atom, next atom to ion, next ion to aqueous ion. So here bond dissociation order, bond dissociation energy order of halogens. Remember like this, CBFI. CBFI means Cl2, Br2, F2 and I2. This is bond dissociation order. So F2 has low bond dissociation energy. Therefore, it can form atoms easily. Next, hydration energy will be very high. High hydration energy. So, due to low bond dissociation energy and a very high amount of hydration energy, F2 is most reactive. Therefore, option will be B. So, due to these two reasons, dissociation is very less in case of F2 and hydration also very high. F2 is most reactive. Therefore, F2 will be known as superhalogen. Due to its highest reactivity. Next. Which of the following atoms have the highest first ionization energy? So here rubidium, sodium and potassium are S block and scandium P block element. So when compared to S block, ionization energy of D block will be high. Therefore, scandium has highest first ionization energy, means we can write it as IE1. So ionization of D block greater than ionization energy of S block. So due to this reason, yes, scandium will be having highest first ionization energy among four elements. Therefore, option A. Next one. The increasing order of atomic radii of group 13 elements. Group 13, it is also known as third A group or boron family. Boron family. The elements are boron, aluminum, gallium, indium, thallium. So atomic radius generally increases from top to bottom in any group. That means boron, aluminum, gallium, indium, thallium. So this is expected order. So but due to here gallium has D10 configuration. So D10 configuration is poor shielding effect. So due to poor shielding effect of D10 configuration of gallium, there will be contraction in radius. Therefore, boron, gallium, aluminium, indium, thallium. So this is actual order. Actual order. So here this is anomalous pair due to poor shielding effect of D10 configuration of gallium. It will be having small radius when compared to aluminium. So here radius of gallium less than aluminium. Very, very important for competitive exams. All competitive exams. Expected order top to bottom increases, but here between aluminium and gallium order will be reversed. That is due to poor shielding effect of D10 configuration of gallium. Radius will be smaller when compared to aluminium. Next one. The electron configuration with the highest ionization energy is. Here 4 elements are given. Take Ne 3s2 3p3. 3s2 is completely filled. And 3p3 half filled. Both are stable. Both configurations are stable. Therefore, very high amount of energy is required to remove electron from this configuration. So here observe option A also. This is also completely filled 4s2 and 4p3 also half filled. So A is also stable, but when compared to C, A is less stable. Why? Because in C option, third shell is present. In A option, fourth shell is present. Third shell is placed nearer to nucleus. Therefore, nuclear attraction will be more on C option. Therefore, option D. High ionization energy. Neon core 3s2 3p2 is placed nearer to nucleus. Therefore, nuclear attraction will be more on neon core 3s2 3p3. Therefore, ionization energy highest for neon core 3s2 3p2 due to stable configuration, and also it is placed nearer to nucleus. Next one. So here given molecule CH3, I am writing structural formula CH double bond C double bond CH2. Here I will write hybridizations. Carbon atom is bonded to 4 sigma bonds, 4 single bonds. This carbon will be sp3 due to 4 sigma bonds. All are sigma bonds. Next, this carbon atom is attached to 3 sigma 1 pi. Therefore, it is sp2. And this carbon atom is attached to 2 sigma 2 pi. Therefore, it is sp. Next, this carbon atom is attached to again 3 sigma 1 pi. Therefore, sp2. See, in the given compounds, which carbon will show maximum electronegativity? electronegativity order of hybrid orbitals, that is sp, sp2 and sp3 is sp3, sp2 and sp. This is increasing order of electronegativity. So sp hybrid orbital is most negative, most electronegative. So here sp hybridization is present on third carbon. Therefore, option 3. Third carbon can show maximum electronegativity due to sp hybridization. Next one. This is also important question. The correct order of stability of Al plus, Al2 plus, Al3 plus. So in aluminium, Z equal to 13, that is 1s2, 2s2, 2p6, 3s2, 3p1. Or we can write up to 1s2, 2s2, 2p6, we can write neon core 10 electrons, 3s2, 3p1. Aluminium configuration. Next, Al plus, removal of p1 electron. It gives neon core 3s2. Al2 plus, neon core 3s1. Al3 plus, just neon core. This is noble gas, most stable. Next, so here completely filled configuration. Therefore, it will be stable. Next, 3s1 unstable. Now give the order. First, Al3 plus is highly stable due to inert gas configuration. First, Al3 plus. After that, Al plus has completely filled configuration in valence shell. That is stable. After that, Al2 plus. Therefore, option will be D. So, based on configuration, we can arrange this order. Next one. Decreasing order of ionization potential of following elements. So, here neon, magnesium, aluminium, sulfur, phosphorus, chlorine are given. Next, magnesium to chlorine, third period elements. This is second period. So when compared to third period elements, second period elements will be having more ionization energy. Therefore, neon will be written at first. Next, compare here third period. For third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So, sodium less than magnesium, but magnesium greater than aluminum. Remember this order, anomalous pair. So, due to completely filled configuration in valence shell. Next. When compared to sulfur, phosphorus has more ionization. Next, after that Cl. Here it will be also reverse. Phosphorus has half filled configuration. Therefore, first neon, next chlorine, next phosphorus, sulfur, magnesium and aluminum. This will be the order. Ionization energy order. Therefore, option B. See next question. In the formation of chloride ion from isolated gaseous chlorine atom, 3.8 electron volts of energy is released, which would be equal to. So here it is given conversion of gaseous atom to Cl minus gaseous ion. This one neutral atom and uni negative ion. So this process is electron gain enthalpy, and the reverse process is ionization enthalpy. That means simply we can write magnitude of electron gain enthalpy of atom will be equal to ionization of uni negative ion. Very, very important. That means simply we can write electron gain enthalpy of Cl will be equal to ionization of Cl minus. This is the answer. So electron gain enthalpy and ionization energy are opposite process. So in forward reaction, 3.8 electron volts of energy is released. In reverse process, 3.8 will be absorbed. So therefore, option will be D. Electron gain enthalpy of Cl is ionization of Cl minus. Next one. So which will have maximum value of electron affinity, O power x, O power y or O power z. Here x, y, z are 0, minus 1, minus 2. Here simply x is 0, y is minus 1 and z is minus 2. So we know electron affinity of atom greater than anion of that atom. Electron affinity of atom greater than anion of that atom. So therefore OX has maximum electron affinity. Therefore option A. So neutral atom can accept electron very easily when compared to anion due to inter-electronic repulsions. That means O minus will be formed very easily when compared to O2 minus. Here electron affinity comparison. Electron affinity of carbon greater than oxygen, fluorine less than iodine, Cl minus less than Cl, S is less than oxygen. Here we have to compare. So electron affinity of oxygen greater than carbon. So due to high Z effective in case of oxygen. We know this. Next, electron affinity of halogens Cl, F, Br and I. This is for halogens. Next, electron affinity of Cl greater than Cl minus. So due to electronic repulsion. Due to inter-electronic repulsion. Next, electron affinity of sulfur greater than oxygen due to very small size. So therefore here option C. Carbon greater than oxygen, wrong. Next, fluorine less than iodine, that is also wrong. Next, S is less than oxygen, that is also wrong statement. Cl minus less than Cl is correct. Due to inter-electronic repulsion. Next, after filling np orbitals, next orbital filled will be. So according to Above principle or n plus L rule, Above principle, after the completion of NP shell, comma, the next electron entered in n plus 1 s orbital or shell. This is based on energy rule, n plus L rule or Above principle. After completing NP, next electron enters into n plus 1 s option. We will take one example. You can take 1s2, 2s2, 2p6, 3s2. So this is the configuration of magnesium. See here, after completion of, say this is Np, this becomes n plus 1 into s. After completion of 2p, electron will be entering into 3s orbital or 3s option. Therefore, option will be D. N plus 1 s. Next question. So out of Na plus, Mg2 plus, O2 minus and N3 minus, the pair of species showing minimum and maximum IP would be, ionization potential would be. Next. So here N3 minus is given. Next, O2 minus, Na plus, Mg2 plus. So all these are isoelectronic species. Isoelectronic species. So atomic number increases in this order. Atomic number Z. Then size will be in this order. Size will be in this order. So therefore size order N3 minus, O2 minus, Na plus and Mg2 plus. This is size order. So minimum ionization means size will be more. minimum ionization energy is N3 minus due to large size. Next, maximum ionization energy size must be very less, Mg2 plus due to small size. So therefore option C, minimum ionization N3 minus due to very large size and maximum ionization energy Mg2 plus due to very small size. Next, the electronic configuration of 4 elements given 1, 2, 3, 4, which is not true. We have to identify wrong statement. So here one is, that means first option, Xenon core 6s2 is S block. We know S block elements are reducing agents. Therefore, one is correct. Next, 2. Second one is F block element. F block element. Third configuration is P block. So in that halogens. Halogens are having high electron gain enthalpy. That means high negative electron gain enthalpy values. Next, fourth option, D block. They can show variable oxidation states. Here which is wrong. So second one, option B. Because 2 is F block element. Here D block element is given. Last element of F block. Simple question only, theoretical question. Next one. The correct order of second ionization potentials of CNOF. So after removal of first electron, carbon, nitrogen, oxygen, fluorine, after first ionization, they will become, after IE1, C plus, N plus, O plus and F plus. So after removal of second electron, which is IA2, it becomes C 2 plus, N2 plus, O2 plus and F2 plus. So here C plus configuration. C plus configuration is 2p1. N plus configuration 2p2. O plus configuration 2p3. So which is half filled configuration. F plus configuration 2p4. So out of 4 positive ions, O plus will be having highest ionization due to half filled configuration. So first it should be O. So after that we know F, halogens. After that nitrogen, which is more negative. At last carbon. This will be the order. So option C, O, F, N, C. So O will be highest due to half filled configuration. After that halogens. Next group 15. After that carbon. So based on periodic property. Next one. So IP1, IP2, IP3, IP4, IP5 values of element are given. 7.1, 14.3, 34.5, 46.8. 162.2. The element likely to be. So how to calculate? Here there is large gap between IP4 and IP5. So this is, say this I1, I2, I3, I4, I5. So large gap between I4 and I5. Therefore, the element will be having 4 valence electrons. Removal of fifth electron will be very difficult due to very large value. Therefore, there should be 4 valence electrons in given element. The element has 4 valence electrons. Therefore, it belongs to 4th A or 14th group. So here 14th group element is silicon. Therefore, option B. It is very difficult to remove fifth electron. Therefore, there should be 4 valence electrons. So after the removal of fourth electron, it will be having noble gas configuration. Therefore, I5 will be very high. Next. The atom having valence shell electronic configuration 4s2 4p2. Electronic configuration is 4s2 4p2. So what is the position? Maximum value of n value, which is principal quantum number, gives period number. So here principal quantum number maximum value 4, therefore fourth period. Next, sum of ns and np electrons equal to group number, that is equal to 2 plus 2, 4. So period number 4, group number 4. Group number 4 means 4th A group, or we can say 14th group. 14th group element. So option C, group 4th A or 14th, period 4. Next question. XX bond length is 1.00 angstrom units and CC bond length 1.54. If electronegativities of X and C are 3 and 2 respectively, then CX bond length. So here direct formula, bond length CX equal to radius of C, radius of X 0.09 into difference of electronegativity. So very important. Radius of C, half of the internuclear distance, 1.54 by 2. Next here 1.00 by 2, 0.09 into difference of electronegativity 1. So therefore 0.77 plus 0.5 minus 0.09, which is equal to 1.18 angstrom units. Therefore option B. If there is electronegativity difference, this will be the formula to calculate bond length. formula for bond length 1.18. Next question. The pair with minimum difference in electronegativity is. So, for phosphorus, electronegativity 2.1. For hydrogen also 2.1. So, therefore, these two will be having P and H. Minimum difference of electronegativity. Therefore, option will be C. Both are having same electronegativity value. So, difference is 0, which is minimum. For remaining pairs, there is some difference. Simple question only. Next. Ionic radii of N3 minus O2 minus F minus. N3 minus O2 minus F minus. These are isoelectronic. Isoelectronic species. So in case of isoelectronic species, see here atomic number 7, 8 and 9. So atomic number increases in this order. Therefore, size increases in this order. So size order is N3 minus greater than O2 minus greater than F minus. So compare the values. First value should be very high, 1.71. Next medium, next small. Therefore option C. So as the atomic number increases, size decreases in case of isoelectronic species. Very, very important. Next one. Given configuration, electronic configuration 4d4 5s1 belong to. So here group number in case of D block equal to total number of Ns and N minus 1d electrons. So that is 4 plus 1, which is 5. That means fifth B group. Option C. So for D block elements, group number will be equal to total number of Ns and N minus 1d electrons. Fifth B. Next. The order of electronegativities of nitrogen, carbon, silicon and phosphorus. So for carbon 2.5 we know. For nitrogen 3. Next silicon 1.8. Next last phosphorus 2.1. Therefore order nitrogen first priority, after that carbon, next phosphorus, next silicon. So order will be D. Electronegativity values. based on Pauling scale. Nitrogen most negative among 4 elements. Next question. See, Mulliken scale of electronegativity uses the concept of Mulliken scale of electronegativity depends on ionization energy or ionization potential and electron affinity. So electronegativity on Mulliken scale Xm equal to IE plus EA by 2. When IE and EA are in electron volts per atom. This is direct form. Average of IE and EA. Ionization energy, or you can take ionization potential also. So option C. While Pauling scale depends on bond energies. Next one. Fourth shell of atom contains 4s, 4p, 4d, 4f subshells. Which subshells are not filled? Not filled in any fourth period elements. In fourth period, first S block, therefore 4s. After completion of 4s, next 3d, next 4p orbitals are actually filled. So first 4s, S block, next 3d series, next 4p, P block. This is S block, B block and P block. So which are not filled. Not filled means 4d and 4f. 4d, 4f, option D. 4d and 4f not filled. Next one. So very important. Which is not anomalous pair of elements in Mendeleev's periodic table. So Mendeleev's periodic table. Anomalous pairs are first argon, potassium. This is one pair. Cobalt, nickel, second pair. Tellurium, iodine, third pair. Next, thorium and protactinium. These are anomalous pairs in Mendeleev's table. So these are arranged in decreasing order of atomic weights. So there should be increasing order, but here for these 4 pairs there is decreasing order of atomic weight. So argon, potassium is there, cobalt, nickel, tellurium, iodine. Option D is not present. Remember 4 pairs: argon, potassium, cobalt, nickel, tellurium, iodine, thorium, protactinium. So this is end of model questions. In next video I will explain synopsis and exercise questions. So all the best and thank you.